Here's a free response question I'm going to do for you right now. This is a BC calculus question. Consider the family of functions f of x is equal to this, where k is a constant. Find the value of k for k greater than 0 such that the slope of the line tangent to the graph of f at x equals 0 is 6. And then if k is negative 8, they want us to do this, and then for k equals 1, find the value of this or show that it diverges. So just kind of scanning over that, the fact that there's a question about whether this diverges or not, that alerts me to the fact that there might be some kind of improper integral thing, and if you're taking the integral like either across or right up against a vertical asymptote where the denominator is 0 here, then that is a improper integral situation. So let's see what we can do here. Find the value of k for k greater than 0 such that the slope of the line tangent to the graph at 0 is 6. Okay, so I need to find the derivative of this. You can either use the quotient rule, or you can rewrite it as x squared minus 2x plus k to the negative 1, and then use the chain rule. Both of those are fine. I'm just going to go ahead and use the quotient rule because I haven't done that in a while. So I just feel like using the quotient rule. So low d high minus high d low over low low. And I want this to equal 6 when x is 0. So when I plug 0 in, I want it to equal 6. So when I plug 0 in, well, this is gone. So when I plug 0 in here, I get negative 1 times negative 2. That's 2. When I plug 0 in here, I get k squared, and that's going to be equal to 6. So if I do some fancy cross multiplying, it looks like k is going to be equal to plus or minus the square root of 1/3. But they said that we only want the positive ones, so k is equal to square root of 1/3. That wasn't too bad. Alright, for k equals negative 8, then find the value of this integral. Okay, so if k is negative 8, then f of x is equal to 1 over x squared minus 2x minus 8. And I want to take the antiderivative of that. How do I find the antiderivative of something like this? Well, that looks something that can be like something that wants to be factored. So it's x minus 4x plus 2. And this is a partial fraction decomposition situation, isn't it? Got to be ready for anything, right? Okay, so when I do the little game here, I got ax plus 2a plus bx minus 4b. If you're thinking to yourself, oh boy, got to go back and review that. This is section 8.5. And that all is equal to, when I put together, that's the numerator. When I combine these, that just has to be equal to 1. So the x terms, there is no x over here, so that means a plus b must be 0. And the 2a minus 4b is where the 1's coming from. That's that. So solving this system, I guess I could just multiply this by 4 and add it to this. That's one way to do it. So that would give me 6a. The b's would cancel out. 4 times 0 is 0 plus 1. So a is 1/6. And since a plus b is 0, b must be equal to negative 1/6. Okay? So that means I can rewrite this. Instead of finding the integral of this version of it, I can find the integral of this version of it, where I have 1/6 times 1 over x minus 4 minus 1/6 times integral, or 1 over x plus 2. Sorry, didn't do integral yet. And I'm going to do that from 0 to 1. So the antiderivative here, 1/6 natural log absolute value x minus 4 minus 1/6 absolute value x plus 2. Oh, I forgot the natural log there. And not plus c, because this is a definite integral. So however you want to do this, you could certainly factor the 1/6 to the outside. You can also combine the natural logs if you want. So that's the same as 1/6 times the natural log of x minus 4 over x plus 2. You don't have to combine them like this. You don't have to factor out the 1/6. You can just go ahead and start plugging stuff in. 1/6 times natural log of, when I plug 1 in here, I get negative 3 over positive 3, which is negative 1, but it's in absolute value signs. So it's natural log 1, which is 0. I'll simplify that in a sec. And then when I plug 0 in, I get negative 4 over 2, which is negative 2. Absolute value of that is 2. You could also combine those as natural log 1/2, or you could do negative 1/6 natural log 2, or 1/6 natural log 1/2. Those are equivalent to each other. And that's it. That's what you have to do there. And part C, for k equals 1, find that or show that it diverges. Okay, so let's see if we can do that. Just going to move on to a new piece of paper. And I'm going to rewrite the problem. So for part C, I'm trying to find the integral from 0 to 2 of 1 over x squared minus 2x, and now they're saying that the k is equal to 1. Okay? Well, that's the same as x minus 1 squared. All right? And the thing that we have to recognize here, and hopefully the fact that they are talking about divergence might help us recognize that we are integrating here over a vertical asymptote. So what does that function look like? You don't have to think about this necessarily, but if you did, I mean, you know what the 1 over x squared graph looks like. So this is 1 over x squared, but shifted 1 unit to the right. So we're trying to find this area, and maybe it exists, maybe it doesn't, but we're going to have to integrate right up against that. Now you could find both integrals, but because of the symmetry of this, you could also just do like the integral from 0 to 1 and double that. That would work. It's up to you. But there is that symmetry here. I'll pretend I didn't recognize that. So what I have to do is I need to find 0 to 1 because of that vertical asymptote. I can't just find the antiderivative of that, plug the 2 and the 0 in, because I'm going across a vertical asymptote. So 0 to 1, 1 over x minus 1 squared dx plus 1 to 2. These are going to be equal to each other if they exist, they will be the same number because of the symmetry of this. But I'm pretending I didn't know that. Okay. Now, that's almost good. I guess I would just like to do a quick u substitution on that, maybe. So if u is equal to x minus 1, then du is just equal to dx. So basically we're just shifting the values of these. But that's going to make it equal to integral new u numbers would be -1 to 0. And that would be 1 over u squared, or u to the minus 2 du. And same substitution on this one. New u numbers would be 0 to 1, u to the minus 2 du. And the antiderivative of u to the minus 2, add 1 to the exponent and divide by the new exponent. I got that from -1 to 0 plus that from 0 to 1. And when I plug in the 0, I get -1. This is the same as 1 over u, of course. 1 over 0. Plugging in a -1 here, minus -1 plus -1 minus -1 over 0. So I have, these are infinities showing up here, so that is no good. Remember, the way this game works is that sometimes these things resolve themselves, but they resolve themselves because, or in situations where once you plug in your 0 or your infinity, if it's that type of improper integral, this expression here will take care of itself and you will actually get an answer. You might get like a 1 over infinity, but that goes to 0. So in this case, we are divergent.